going to be about pardon me, ES6 classes. And ECMA Scripts 2015 came with classes as a new feature, and you should understand that in JavaScript, almost everything is an object, and objects have prototypes. So JS is object-based, and most objects have prototypes. So objects have prototypes. Now, what are prototypes? Prototypes for objects are like fallbacks. And when an object
I can't hear.
I think he lost connection. Let's wait a bit.
hello, are you guys with me?
Yes, we can hear you.
Yes.
All right. So JavaScript is object-based. JavaScript is object-based, and objects have prototypes. And I was saying that prototypes are like fallbacks for objects. So when you check when an object is checked for a property, if the property isn't there, the object's prototype is checked for the property. And I'm just going to demonstrate how that works shortly. I'm going to demonstrate how that works shortly. Now, if we have an object, let's call it obj1, or let's just call it obj. We have an object, and then we can say A5, B6, and then C, and we can say print, and we can say console log this dot A, this dot B. Now this is just a regular object. It's called the object dot create method. What we simply do is call the object dot create method, and the object dot create method can create an object which would have obj as its prototype. And then we simply write the proto here, sometimes they call it proto here, of the object, and then here we write the properties. So if we're creating an object using the object.create syntax, obj is going to be the prototype of the new object that we are creating. And then in here, we're going to use properties. And for every object, every function, to get the prototype of it, we call the object dot get prototype of. Get prototype of. Now before we go ahead, let's call this function for the obj object. And by default, every object has this prototype. And then the parent prototype is object, I think it's object.object. That's the topmost prototype. So a prototype can also have a prototype. And then there can be a prototype 3 in JavaScript. So I'm just going to run this. Oof, I didn't log into the console. I'll log it quickly. And just so when I log this to the console, you see that the prototype of that object is this. So this is the prototype of the object in question, of the object OBJ, the prototype of the object OBJ. And functions as well have prototype. So I'm going to create a function, and then I can call it fxn equal to, let's make it an array function. And we can return, let's just return 5. And we can run this same object.get prototype
I'm
for
sorry.
fxn.
I'm sorry, but why no error? The object
Sorry?
the object without const or let, no error in this code. Why the object above without const or let obj and
line
why-
4, I
Sorry,
think. I think he's asking like why line 4 doesn't have let or const.
oh yeah.
when you run the code not throw errors. Why?
Why it doesn't have any error? Well, with JS you can create, it isn't good practice, but then you can create variables without using the constant let object. And it is my bad, I'm so used to Python, I forgot the constant let object. But when you use strict, when you decide to use strict, or you decide to use some linter, they would make sure that they would force you to use the const or the let object to create variables. So that's my bad. Sorry about that. I would run this code again. I'll run this code again, and then this is the prototype of this object. Now, what you should understand is that the prototype of every object has to be an object. And that's why when I run this, it is going to return an empty object. And I'm going to explain in a second why it returns an empty object. Now, this class is all about classes. And before ES6 came in, if you wanted to create classes, or if you wanted to implement object-oriented programming in JavaScript, you had to use constructor functions. You had to use constructor functions. And before we talk about constructor functions, I'm just going to show you a little about factory functions. Now, factory functions, as the name implies, a factory that helps you create objects. So, assuming we have a function, let's call it fact. Assuming we have a function fact that creates an object, and the fact takes two variables. Okay, let's take 2 arguments rather. Again, it creates an object, or it returns an object A and B. Now you can agree with me that this factory function fact is creating an object for you. And you can say the same thing for classes. Classes create objects for you. And when factory functions was there, back then, factory functions was there, and then other versions of JavaScript came, and constructor functions was a more elegant way to write factory functions. We can, I don't know, cut lines and cut corners and do what constructor functions can do with factory functions, and do what classes can do with factory functions. But then you should understand the differences between, and you should read more about factory functions, constructor functions, and classes. Now, I'll show you one of the difference between this factory function and a constructor function. Now, a constructor function, I'll just use the function keyboard here, and let's call it construct. Let's take A, let's take B. And what this constructor function is going to do is is going to create an object, and this dot A is going to be equal to A, this dot B is going to be equal to B. I'll comment this out. Well, no need. I'll just call this function instead. Now, to call this function, this is the constructor function I'm talking about. To call this constructor function, you need to make use of the new keyword. You need to make use of the new keyword, right? And I could say new, let new object equal to new, then you call the constructor function. You construct, and then you pass in your variables 5, and this could be anything. It could be a string, it could be a number. Now I'm going to print the new object created. The moment I run this, you see that a new object has been created from the constructor function. And you can see it evident in the construct, with the construct that is being printed out with it. So constructor functions and classes are very, very similar. Classes is the new syntax that came with ECMA script 2015, and it gives you a more elegant way to write constructor functions. I want to find out if there's any question or if there's any clarification so far before we go into classes.
I have a question.
Okay.
All right, I want to understand prototype. You made mention of prototype just not quite long ago. Like I know of objects.prototype, that all objects inherit from the object of prototype. But you also said something like, for example, let's say facts, for example, as a prototype of itself. Like, what do you mean by like the prototype you talked about?
Okay, so in JavaScript, functions inherit from function.prototype. So each function inherits from function.prototype. And I would show you an example here. If you want to add, when you're dealing with constructor functions, if you want to add a function or a method to this function, you can say construct dot prototype dot, and then you can add the method name. Now you're going to agree with me that this construct is a function and it isn't an object, right? Are you with me?
Yes. Yeah, I'm here.
Construct is a function and it isn't an object. But to access the prototype of construct, you use the dot prototype. And dot prototype is an empty object which is attached to the prototype, which is attached to the function dot prototype. So every function has its prototype, which is function dot prototype. And then when you want to access it, you write the function name. By the way, function dot prototype is an empty object. Function dot prototype is an empty object. I'm going to send maybe a link to an article which would explain this more. So function dot prototype is an empty object which is attached to every function's prototype. Function dot prototype is just an empty object which is attached to every function prototype. And now for this constructor function, if you want to add a method to it, you access the method's prototype and then you add the method to it. You know, if you want to add another property to an object, let's say obj1, you want to add another property to obj1, just simply write dot and then you write the property name, yeah, and then you give it a value. So if you want to add a property to a function's prototype, yeah, you have to access the prototype of that function. And then, like I said earlier, the prototype of every function is function.prototype, which is an empty object. So JavaScript being object-based, even functions have their own prototype, which is function.prototype. Arrays have their own prototype, which is array.prototype. JavaScript being object-based. And then the parent prototype is object.object, yeah? And all of them have that as their at the top of the family tree. Every JavaScript object
Hello,
is very
your voice cutting up a bit.
it's variables, numbers. This is the using number just this is you can construct creating that is going to
There is a problem of sound.
Daniel, can you hear me? Hello? It's okay, let's wait a bit. Hello, Daniel? Okay, let's just wait.
every function has its prototype as function.prototype, which is an empty object. Same thing with every constructor. Every constructor's prototype is an empty object which we can attach methods to. So it's just another subtle way or another way of, say, creating a class and then adding methods to that class. So for example, I want to add a method to construct, I say construct the prototype. Sorry, I've written it here. Construct dot prototype, and we can call this print. And then this can be a method that I attach to this function's prototype. And the fact that it's attached to this function's prototype, every object that is created from it can have access to that method. Every function that is created from it can have access to that method. And the question that was asked earlier, for fact, if I'm getting this correctly, for fact, which is a function, what is the prototype of fact? I don't know who asked the question, and I don't know if I've confused you or convinced you or answered the question.
Thanks. You can continue.
Okay.
Sorry, I have a question. So, when constructing or when creating the constructor function, I want to know
Yes.
the construct, is it a keyword, dedicated keyword, or is just the name of the function?
It's just the name of the function.
Okay, all right. Thank you.
It's just the name of the function. Any other question? Can I go on?
Yeah, go ahead.
All right, so constructor functions, factory functions, classes. Constructor functions, factory functions, classes. Factory functions are the most primitive way of creating objects, and then constructor functions came, and then classes came. Sorry, I would, just admit some people. So factory functions, most primitive way, constructor functions came, and then classes came. Now you're going to see a lot of similarities when we're talking classes and when we're talking constructor functions. Now, the first similarity you're going to see is that they're both created, instances are both created using the new keyword. And then you're going to see the this keyword here. And I want to know if anyone has any problem with the this keyword. I believe everyone is clear on how this keyword works. I believe everyone is clear on that. So now on to classes. I'll comment all of this out. And I'll just leave this here. And for classes, I'm going to call this construct2. Yeah, construct2. And with classes, to create or the constructor function for classes, yeah, when you put in your curly braces, use the constructor keyword, which is going to act as the constructor function for classes. Now, classes, if you want to add methods for this, you're not going to do it curly brace inside the class block. So when I have my constructor here, I'm going to have my methods inside of it. So everything is going to be inside the class block. Right, someone said the shortcut for commenting, just use control and /, and then you'd comment it for you this way, control and /. And then the different, then for adding methods to our class using the constructor function, you need to write the constructor function name, and then the prototype, and then say you want to write print, this is going to be the method, and then indicate there is a method this way. Indicate there is a method this way. So I want to add a method to construct class, which is implemented using the constructor method. I simply refer to its prototype, which is an empty object, and then I am going to add to its prototype. Now, instances of this, imagine I have an instance of construct, then the instance name is instance. If I do something like instance.print, this instance isn't going to have print as an instance method because we don't have anything like this.print. Agreed? We don't have anything like this.print. But then it's going to have access to print because, like I mentioned earlier, prototypes are like fallback. When it checks that print isn't a property of instance, it's going to check its prototype. And its prototype has print as its property. So it's simply going to call the prototype of it. And with this, you'd notice that you can modify to string methods of particular functions of some objects. You can modify it to string method. You can modify its its passint method. And how that works is the object itself, when you modify or when you add a passint method to that object itself, it doesn't have to check prototypes of it because the object itself has the method, and when it finds it in the method, it ignores the prototype. It ignores the prototype. So that is just by the way. We're talking about the class syntax here. Talking about the class syntax here. And the class syntax, simply writing your constructor, and then you put in arguments for your constructor. Now to add instances on objects created from the construct2 class, you have to use the this keyword. You have to use the this keyword. And then you can do something like this.a equals to a, this b equal to b, this dot a equal to a, this dot b equal to b. And when you want to call it, same way, when you want to create an instance, same way you created an instance for this using the new keyword, you're simply going to do new, let's call it instance, ins, is equal to construct2. Then you pass in your arguments, which are going to be passed to this constructor. So I pass in my arguments, which are going to be passed to this constructor. And I can do the same thing here, just to demonstrate that they are similar. I can do the same thing here. Oof. Const. Here. I can do the same thing here. First, const inst new construct 5 7. So from line 11 to line 16 is one way of implementing. Line 11 to line 16 is one way of implementing, say, object-oriented programming in JS. Oh, this keeps happening. Of implementing object-oriented programming in JS. And from line 11 to line 16 makes use of the constructor function. And then from line 19 to line 26 makes use of the class keyword, which was introduced in ES6, ECMA script 2015, makes use of the class keyword. So this is a more elegant way of writing it, and this is similar to other programming languages.
Sorry to cut you off. Like, can you check if someone wanna go in? Someone wanna go in, but he couldn't.
Okay.
Make sure it is yellow. Thank you.
Well, the class is about ending because we are limited to only an hour. I don't know if it's possible for you to create another link so you can be the host and let people in. Hello, can you hear me? Hello, can you hear me? Can anyone hear me?
Yeah,
Yes,
yeah,
we can hear you. We can hear you.
Yes, yes.
So, okay. Can you just add the new link so we can all hop in there,
Okay.
and then you can be
Okay,
the host?
Okay, give me a second.
Okay. Yeah. I wanted to ask if it's possible for us to wait maybe a minute so other people can join.
Yeah, let's wait. Let me post the new link.
So before we hopped into the new room, we're talking about creating instances of objects, creating instances using the constructor keyword, using the constructor method rather, and then using the class keyword. And then I gave two examples, and in the example we can see that these two do the same thing. And this is using the constructor method, which creates a function and uses the this keyword to create instance variables. And then we want to create an instance from it, we're using the new keyword and we're calling that function. And it's similar here when we're using classes. We use the class keyword, we create a class, and the constructor for that class makes use of the constructor keyword. And that constructor keyword is going to act like this function here. But the difference is that this function can have any name, and then the constructor keyword has to use the constructor method rather has to use the constructor keyword. And when we're creating an instance of it, was using the new keyword which was used earlier. We're using the new keyword which was used earlier. And classes don't just help us create variables only. Classes can also have methods attached to them. And with this earlier, I was saying to attach a method to this, we simply write construct.prototype dot, and we give it an arbitrary method name. Then we can see that it is equal to a method, where we can see it's equal to a function. So we write the name of the method, the function, does prototype, give it an arbitrary method name, and indicate that it's equal to a function. And this function is a method because it is a function of a class. Yeah. To do the same thing, comment this. To do the same thing when we're using the class keyword, we simply go into the class block and then we attach a method to it. And when we're attaching a method to it, we don't make use of the function keyword, but we don't say a property is equal to a method. Someone left a comment. We don't say a property is equal to a method. We simply write the method name, same way we do it, same shorthand we use when we are defining a method inside an object. We're going to use the same shorthand inside of the class block. So what am I saying? We have an object, say let's obj. When we have an object, I want to add a method or a function to that object. We simply write the function name. This is the shortcut in ES6 in ES6. We simply write the function name, no need for the function keyword, and then we create space for its argument, and then we write the function block. We can do the same thing here, and then we are not going to be punished. So you write your method name, giving space for its argument, and then put in the method block. Then this method can do whatsoever you want whenever you call it. I don't know, I'll just get rid of this. This method can do whatsoever you want whenever you call it. And when you want to refer to variables, you also need to make use of the this keyword. Same thing as using the self keyword in Python. When you want to refer to variables or instance properties, you make use of the this keyword. So if I want to say print A and B, I want to log this.a, this.b. So I console.log this.a and this.b. Now with classes, we are not limited to only methods. We can also have getters and setters, which can help us encapsulate things, which can help us achieve encapsulation. So you can just hide the implementation details of some things using your getters and your setters method. And that's just what all encapsulation is about. It's just hiding implementation details. And for getters and setters, we use the get keyword, and then we use the set keyword. So for getters, they are returning. For setters, they are setting a new value. So I don't know if there's any question. I don't know if there's any question. Go ahead.
Yeah, go ahead, please.
All right. So I was saying earlier, we can
There is a
attach
question in
methods.
chat if you wanna check the chat.
Hello?
There is a question in the chat.
Okay. I'll check it now. In your case, get would be an inner function since constructor is a function. Yes, exactly. Someone has written it here. Get will be an inner function since constructor is a function. Yes.
Also there is one above it. Can you see
Okay.
it?
Above it. The last message I saw, the message above is you can implement
Oh,
get.
okay. Let me post it again.
Pardon?
I post it again. I think you did join late after it. Okay,
Oh,
post
okay.
it. Do you see it?
So can I go ahead?
Like scroll down. I did post the old question.
Okay. 1 second. You can implement get to call arguments from constructor. Am I right? Oh yes, you can. Yes, you can. That is from this constructor method, if I'm not mistaken.
I
Right?
believe so, yeah.
Hello.
I think so. Yusuf, you have more question or like more details?
So
You
with
can
this
go ahead
constructor
if you
method,
want.
okay, with this constructor method, you should know that you can overwrite properties even after the constructor has been created. You can overwrite properties even after the constructor has been created. And like I said, there are backdoor methods and there are ways you can cut corners to implement the get keyword, to implement your getters and your setters. But then when after creating the instance, there may be subtle differences when you're calling it. With classes, it hides so many implementation details and we can simply call get A and get B. And for this, how I know you can do it is you access the prototype of it and then you make changes to it. You access the prototype of it and then you make changes to it. Oh, this should be capital letter. You access the prototype of it and then, sorry, you make changes. Pardon me, I'll just let me correct this code. F. It's giving me an error. I don't know where it is. Oh yeah, it's here. Never mind. So for us to do it this way, we can attach getter method and we can attach setter method to this. But then when we're calling it, we need to make use of the get or the set. We need to make use of the get, maybe set A, and then it's going to reset the this, or we need to make use of get A, and then we can say new A. But then when we're calling it, we need to make use of this keyword. So classes that came with ES6 with ES6, I keep saying ECMA 2015. just gives you the getter and the setter, and then it hides the implementation details of the getters and the setters. And in the tags that we're given, yeah, they were making use of this.a, and then they were making use of this.b. Now, when you're calling them, you're doing something like get A, and you're doing something like get B. Now, doing it this way, when you create an instance, for construct 2, the instance variable name is going to be underscore A and underscore B. But then when you're modifying it, you're using A and you're using B. So I can do the same thing here. A, B. And then when I'm modifying it, I can do something like get prototype A, which is going to be a function that is going to modify A, get prototype B, which is going to be a function that will modify B. Also, when we're setting, set B is also going to be a function that will modify B. Set A is also going to be a function that will modify A. For setters. So for getters and for setters. Getters help you get instance variables, which simply returns ES6. Then setters help you change the values of instance variables. Yeah, help you change the values of instance variables. So we can call this new A, and then we can say this dot A equal to new A. All right. So I'm simply going to get rid of every messy code and just leave just work with the class method only, just so that we have more space and I don't have to keep scrolling and scrolling. So construct 2, let me log this to the console so it's working properly. Inst. Right. So ins is an instance of the class construct2, and we can see it here. It's an instance of the class construct2, and then we have our instance variables or instance properties as per JavaScript objects. Instance properties, which is underscore A and underscore B. And now I'm going to set the value or get the value of A and B. And to get the value of it, we need to call our get method. And before calling our get method, we need to indicate that this is the instance that we're talking about. This is the object that we're talking about. And the moment we do this, this is the result. The moment we do this, it is returning the value of A. It is returning the value of A. Any questions so far? Any questions so far?
A question for the instance variables or the properties. Do Does the underscore make them private or something?
No, it doesn't make them private. It's just a naming convention. So that when, say, another programmer sees it, he understands that this is supposed to be a private variable.
So
It's just
if let's say outside the class you try to access the variable using the actual the name, let's say underscore A or underscore B, is it going to work?
Yeah, it is.
Okay.
It is. Any other one? Okay, I can see. Okay, so how do we implement the get function? Sorry, I'm reading the questions in the comments. So how do we implement the get function from the class? Oh, I just implemented the get function here. Get A, which is this. Which is this. I implemented it here. I think you mean how we call it. Okay, so for classes, yeah, for classes, I was saying earlier that we have our getters and our setters. And whenever you see get and you see set and you see constructors, know that they are keywords. Know that they are keywords, and these keywords help us implement some functionalities. Now, the constructor keyword helps you create a constructor method. The get keyword helps you create getter methods. The set keyword helps you create setter methods. And when we use the get keyword to create our getter method, we all know that getter method help you return a value of the instance, and we can see it here. So after implementing this getter method, let me comment this. Let me comment this. Right. So after creating it, to call the get keyword, first off, we all know we have to create an instance. So I created an instance, I printed the instance, and now I am calling the get function, which is named A. Know that your get, the name of your get function can be arbitrary, it can be whatsoever you want it to be. There are no rules to it. But then just so I can understand and so other programmers like you guys can understand, I decided to use A. Right? So I used A as the name of the method, and then I simply called it by saying instance.a. I simply called it by saying instance.a. And I should save this. And when we check the output, we can see, where is the line? Line 26. We can see the output of line 26 here. And we can see the output of line 25 here. Okay, still another question. Okay, but if I remove the function and hold on, I'm reading it. But if I remove the function and I console.log ins.a, it won't work, right? The get function. If you remove, okay, this function, oh, it wouldn't work. If you remove this, it wouldn't work. It wouldn't work. It only works because it is It is being implemented inside of the class. That's the only reason why it is working. You're welcome. You're okay. Someone is raising. Go on, go on. You can ask your question.
Okay, please, I have a question.
Yes, sir.
My question is, must the getter and setter be implemented under the constructor keyword under the class?
Okay.
Since it is a method, can it be implemented independently?
Yes, it can be implemented independently, but then when we are calling it, that's using the constructor keyword. When we are calling it, we need to indicate that it is a method. So we have to call it using these brackets. So for example, I'll just write it again. For example, we want to create a constructor function, right? Let me create a constructor function here. I'll just call it const to save time. We want to create a constructor function. It's taking P, it's taking B. Then we are saying this dot A is equal to A, and this dot B is equal to B. And I believe the question is, when you are creating an instance from this constructor keyword, can we implement getters and setters for it? And when we are implementing getters and setters, how do we call the getters and setters?
Yeah.
Okay. So yes, we can create getters and setters. And to create getters and setters for this, I'm going to rewind back. We access the prototype of this function and then add getter method to the prototype of this function and also add setter method to the prototype of this function. And like I was saying earlier, almost every object in JavaScript has a prototype. And the prototypes are fallbacks. Prototypes can also have prototypes. And we have our prototype tree with object.object being at the top of the prototype tree. So everything inherits directly or indirectly object.object. And the prototypes for constructors is an empty object. And how do we access that empty object? Which instances, so I create an instance from this, which instances is going to fall back to? Now to access that object, let's say cons dot prototype dot, and then I can access methods in that object or I can access properties in that object or add properties to the object. Yeah. So I want to add a property. I can say set A. I can say set A. Now I'm adding set A as a property. But then when I add set A as a property and set A is equal to a function, yeah, then set A is equal to a function that is returning B. In order for me to call this setter function, the instance of this, let's call it instance 2. The instance of this of const. Yeah?
I
Instance
thought you
of
said
const,
getter does not return.
pardon me, getter, sorry. Thank you very much. Thank you very much. So the instance of const is going to call this method by saying instance 2 get A. This is how it's going to call this getter method. But for classes, we aren't going to invoke the function using the set of brackets. We aren't going to invoke the function using the set of brackets. We're simply going to write the method name. We are simply going to write the method name. That's using the class keyword. And as I was saying earlier, ES6 came with classes which give you more elegant ways to achieve object-oriented programming. So you agree with me that this is a more elegant way to implement or to call your getter method than, where is it, than this. And this is a more elegant way to write your getters and setters method compared to this. You'd agree with me, yeah? So the class keyword came with ES6, and then I believe it wouldn't have been created if all of this would suffice and if programmers were comfortable with this. So ES6 came with a bunch of goodies, and this is one of it. Class, which is one way to implement object-oriented programming in JavaScript. Did I answer the question?
Yes, you
Was
have.
that it?
Yes, you
Okay.
have.
All right, thank you.
So can I ask a question? Can I clarify something, please?
Yes.
Okay, for this line 24, 25,
Yes.
where you said we have brackets, we don't have to invoke the method.
Yes.
Like I think that we have to actually, even if it is a getter and setter, for as far as
Yes.
it's a method, we actually have to invoke them. Except if it is an attribute, then we don't have to. We don't invoke attributes. So I don't know if it actually worked when you tested it.
Oh, it did work. It worked. So this is supposed to print. It's supposed to print 5. The second one is supposed to print 5. And if I run it, we can see that the first console.log is printing the object itself here. And then the second console.log is printing the property, the A property, which is 5 here. So you can see it. Let me minimize the screen so you see the implementation here. And then just so here's the implementation. Value A is 5, value B is 7. And I'm printing value A using the getter method. And the instance variables names are underscore A and underscore B. So instead
Sorry,
of
okay, so I still want to clarify this very well. That line 14, perform something like an arithmetic operation in 14 multiplied by 2.
okay.
Yeah. So which one? Let me see. I want to confirm.
Okay,
She give us 10.
we did.
Okay. All right.
With the get function, like I said earlier, getters and setters will help you achieve encapsulation. Let me zoom in. Will help you achieve encapsulation. And encapsulation is going to hide the implementation details of variables. Now, if someone doesn't have, yes, okay, if someone doesn't have access to this get method, he would think that get will return 5, but in the implementation details, it is returning 10. And also in the set method, we can use our try catch. I use our try catch. Let me see. Try catch, or we can even throw an error. We can throw an error. Throw an error if we are getting the wrong data type from A. And then all of this is still hiding inside of the set function, which is encapsulation achieved. All of this is hiding inside our set method, which is encapsulation achieved, and encapsulation is just hiding implementation details. Now earlier we're going to do something like in the first constructor, we're going to do something like cons dot prototype dot something, and then when we're doing that method, the implementation detail is out there for everyone to see. But when we're using getters and setters, we can hide implementation details, and we can add more logic into the get method into the set method before setting the value of our properties. So I can do something like if new A, oof, my bad. Type of new A is not equal to number, and then we can throw an error using this. We can throw an error using this. So we can add more logic to our getters and our setters. And then this more logic can help you protect your properties. It can help you protect, excuse me, it can help you protect your properties. And then, just like you mentioned earlier, we can make our getter to return something otherwise, and then we are adding more logic. We can make it return something otherwise by adding more logic to whatsoever. Okay, so how do you call the setter function? I'll get to that. So we can add more logic to whatsoever. How do you call the setter function? Before I call the setter function, I'm just going to add something to the setter block to call our setter function. I would say this dot A equal to new. Call our setter function. Simply say instance dot, oh, this is big. Instance, these are instance dot, then you call the setter function dot A of instance dot A, and then you simply put your equal to, and then give it a value. And with this, you've called your setter function. With this, you've called your setter function. You need not do it this way. You need not do it this way because it works. And I am going to print A here again. And what are we expecting? We are expecting 7. We're getting 14 because, well, this is multiplying by 2. I'll get rid of this. We are expecting 7. So how does this work? Create an instance here. An instance of the class construct2. The class constructor is expecting two arguments, argument A and argument B. So we're passing in argument A, argument B. Do not forget the new keyword. Do not forget the new keyword. We're passing in argument A, we're passing in argument B. After passing in argument A and argument B, we are printing the instance to the console, and that is why we are getting this. and we're getting underscore A underscore B because we indicated that we want the instance property to be underscore A and underscore B. That is why we're getting underscore A underscore B. And now, in order for us to get values of underscore A, like we said, we are trying to show that it is private. We are trying to show that it is private. It isn't private, but then it is good practice to put in your underscore just to show that it is private. So when other programmers come, they see that it is private. Yeah. So we're trying to show that it is private. And that is why we're also implementing our getters and our setters method. And with our getters method, we're calling it A, we're not calling it underscore A. We're calling it B, we're not calling it underscore B. Yeah. And when we want to get the value of A, we implement our get A method, which should return the value of A. And line 14 here, we are returning the value of A. So since line 14 is returning the value of A, let's see it being implemented. To see how it is being implemented, we call the object and then we return the value of A by calling the getA method. But how do we call the getA method? We don't call it like regular methods. This is how we call regular methods, yeah? We call regular methods this way. We don't call it like regular methods. We can simply here, which is A, and we don't need to invoke it like regular methods. And now if you notice this, you'd notice that when we're creating regular objects and then we're trying to give two properties the same name, it's going to flag an error. But right here in classes, I'll get rid of this. In classes, we have the freedom to give two methods the same name. We just have to indicate that one of the methods is a get method and the other is a set method. So this isn't giving us an error. Line 13 to line 21 isn't giving us an error. But then when I am creating, let me come here. I'm creating a new object, yeah? And then I am creating two properties like this. Some linters are going to give you an error and tell you that you have a property appearing twice. But when I am doing the same thing inside of my classes, it isn't giving me that error because with ES6 we have that freedom to give two methods the same name long as the two methods are getters and setters respectively. Any question? Any question? Okay, no question. No question. Okay. So inheritance. And okay, the best way for me to explain inheritance. Imagine you have classes are thought of as blueprints, yeah? So imagine you have a car. A car can have some properties. A car can move. A car can move. A car can reverse move. Let's call it reverse move. That's move in the opposite direction. A car can rev engine, and a car can have speed. It can have a model. It can have a name, and every car can do this. But then sports cars can do what regular cars cannot. And F1 cars can do what regular sport cars can't. But they all possess these properties. And inheritance work in a similar way. Inheritance would take a prototype and improve on the prototype. It will take a prototype and improve on the prototype. So classes are like prototype. Classes are like architectural designs. You can take an architectural design and build 5 houses from it. But then those 5 houses are going to have different furnitures inside of them, but still the same architectural design. It's going to be is very much similar to how inheritance works. You have a parent class, and then a child class inherits properties of that parent class, and that child class can have additional properties to it. Is that understood? Is that understood?
Yes. Well understood.
So, inheritance. How do we implement inheritance in JavaScript? I'm going to get rid of all of these console.logs here, and I'll just I'll use the classic sports car example, or let me use an animal example. So we have class animal, and constructor. Every animal has a name. So this dot name is equal to name. And every animal can speak. Every animal can speak. See, this dot name, say hello. Now I want to create a class named dog, which is going to inherit from the animal class. So it's going to inherit all of these properties. It's going to inherit its constructor, and it's going to inherit its method. And in order for me to do that, I'll say class, give the class name dog. And where is it inheriting from? It's inheriting from animal. So we use extends. Dog extends animal. The moment I do this, it is inheriting all of its properties, is inheriting all of its methods, is inheriting all of its constructor. So you can think of it as dog having animal as its prototype, dog having animal as its callback. And dog, we have the option of giving dog its own constructor. We can give it its own constructor. We can decide to leave it at this. We can decide to leave it at this, and we can decide to create an instance of dog, but it's pretty much going to be same as animal because well, it's empty, and then it's going to be falling back to all of these properties. But say we want to create a constructor for this. We put in the constructor here, and then we put in name. Now, when you're creating a constructor for a child class, you need to call when you're creating a constructor for a child class, you need to call the constructor of the parent class. You need to call the constructor of the parent class. And to call the constructor of the parent class, I make use of the super keyword. So the super keyword is calling this constructor function. Super keyword is calling this constructor function. Now this constructor function is taking in an argument. So I need to pass in an argument. So this super is like a replacement word for the constructor function inside of animal. It's like a replacement word for the constructor inside of this animal. So I say super, which is calling this constructor, and this constructor is taking in an argument. If it is taking in one argument, I pass in one argument. If it is taking in two arguments, we can say name, and then we can say type. Type can be domestic, type can be wild, so you can say this dot type, dot type. This constructor here has to take in name and type, and this constructor here has this function. We need to pass in two arguments, which is the name argument and the type argument. So depending on your number of arguments you're passing, you're invoking the function with as many arguments as required. You're invoking the function with as many arguments as required. Now, for the sake of the prototype that I have been explaining, I am going to overwrite this. I'm going to overwrite this. Now, before I overwrite this, I'm going to create instances of animal, and I'm going to create instance of dog. So the const first animal, let's call it lion. Lion, new animal, and then I need to call the constructor functions with two arguments. So when I put this bracket, it's calling the constructor function with two arguments, name and type. So call this Simba. Type, I'll call this wild. And I'll print it. I'll just print it here so you see it's working. Oh yeah, you can see it's working here. So animal, name Simba, property name type equal to wild. And I'll do the same thing for dog. And I'll call this, let's call this, what should we name this dog? Let's name the dog Zina. Dog, name her Zina. Domestic. Yeah, it's going to do the same thing. Now, what I want to do is I want to call the speak method for animal, call the same speak method for dog, like I was saying. And I want to just demonstrate that this dog class is inheriting everything, including the constructor from the animal class. So I'm just going to do the same thing here. Lion speak dog dot speak. And when I put in lion.speak and dog.speak, sorry, I should go to the new line here. Right. So when I call the speak method for lion, it says Simba said hello. When I call the speak method for dog, it says Zina said hello. Oof, mistake. Dog here. Seen an error. Aha. Aha. So Simba said hello and Zina said hello. Now what can we see here? We can see here that the dog class doesn't have the speak method implemented inside of it. How then do we have access to a speak method for the dog class? We have access to the speak method in the dog class because the dog class is inheriting from the animal class. It's inheriting from the animal class. So it is inheriting all of animals' properties and method. And that is why we do not need to create a speak function inside of the dog class. Now, what if we want to make the speak method a bit more customized and we want to override this speak method for the dog? We can do something. We can say we can implement the speak method here, and then we so like I was saying, when we want to overwrite the speak function in animal, how we do it is we have to implement the speak function also in dog. And then we want to do something like the dog barks, yeah? We want dog to bark. So we could say this dot name says woof, woof. And say this dot name says, extend this dot name says woof woof. So Zina is no longer going to say hello. Zina is now going to say woof woof because the dog function is overwriting the speak function in animal. Earlier, when we didn't have the speak function in dog, it checked for speak function in dog, it couldn't find it, so it had to fall back to the prototype, which is animal. And now when we play this, oh, there's an error somewhere. There is an error somewhere. Hold on, I need to find the error. Oh, it works. So Zina says woof woof. Zina says woof woof. Earlier, Zina was saying hello. Now Zina says woof woof. Because for dog, we have implemented its own speak method. We have implemented its own speak method, which is overwriting this speak method in its parent. So for when you implement a method in the child's class, the method in the child's class is going to be used instead of the method in the parent class. So it's going to be the preferred method. It's just like implementing a property in an object. The property in the object is going to be used instead of the property in its prototype. Instead of the property in its prototype. And with that, JavaScript gives us access to modify the toString method. JavaScript can help you modify the toString method, and you're not modifying the original toString method, you're just creating a toString method inside of an object. So when you call the toString method, it wouldn't fall back to JavaScript's toString method. Instead, it will use the method that you have implemented or you have created. It's the same thing that is happening here. When we are implementing our speak function in the dog, it isn't going to fall back to the speak function in animal. It's going to use this. And then when we have our tree, I'm going to represent our tree like this. When we have our tree, sorry. When we have our tree, and we say these two here are having its prototype here. So we can call this parent and call this child. So each child is inheriting from the parent. So its prototype object is the parent object. If child has a property, child has, sorry, I'm trying to edit this. If child has a property, yeah, and then we are trying to call that property, it is going to make use of the property in the child. But if child doesn't have that property, it is going to check if the property is in the parent. If the property is in the parent, it's going to make use of the property in the parent. If the property isn't in the parent, it is then going to return null. It's then going to return null. And for this child property, the child property might not have toString in it, but then toString can be in the parent. So if it doesn't have toString, it's going to make use of toString which is in the parent. Yeah. But if we decide to implement toString for each child, now you're going to see a different behavior of your toString method because it has been implemented in the child. And I remember there's a task which you have to modify the toString method, or you have to make, I don't know, an object give you a different behavior when you are printing it. So if you have an understanding of how properties or how prototypes work, how the prototype tree works in JavaScript, it can give you access and it can give you some superpowers. And then you can add in properties and you can somewhat overwrite properties. You are not deleting the property from the language, but you're just creating a property inside of that method so that it would ignore what is in its prototype. And it's going to look like you're overwriting the property of the prototype, but you aren't. You aren't. It's like the same example here. When we are implementing the speak method, it isn't overwriting this property. Instead, it is making use of this and then it is ignoring this. It will only make use of this, that is the property in animal, if that property isn't available in the child. It will only make use of the property in the prototype, the property isn't available in the object. It will only make use of the property in the parent class if the property isn't available in the child's class. Any question? Any question?
I think it's clear.
Okay. So is there any... Okay, it's clear. Awesome. Awesome. So I think there's well, with this we've covered the basics and a bit more about classes. And the session is supposed to be for an hour. We've exceeded an hour. You can look into static methods which are created using the static keyword. So just static methods. Static methods are just creating methods for the class itself and not for the instance. And not for the instance. And I'll see if I can share links to Munsif.
Yeah.
Sorry, I don't know if I'm.
Yeah, it's
I'll
right.
see if I can share links to resources to you, to more helpful resources on classes. And if we can do another session tomorrow on promises. We can do another session on data manipulation tomorrow. Hopefully a better time. And I'll run a message through you so we can
Yeah.
vote up
Thank,
when it's convenient for us.
okay. Thank you so much for this. This session
thank-
was amazing. You are
thank you
really
very
good. Thank you.
Thank you very much. Have a good evening.
Have a good night.
Oh, one
everyone.
more. Oh, there's a question. There's a
Yeah.
question. If the static method created for a class instead of the instance, can such method be updated or edited in the instances? I'm trying to understand the question. If a static method is created for a class instead of the instance, can such method be updated or edited instead of the instances?
Hi,
So if I'm
hello. Good,
yes, sir.
good evening. All right.
Good evening.
So you made mention of creating a static method that's for the class, that is for the parent method. If, for
Yes.
example, now this speak method here for the animal, if it's a static method, can such a method be edited in the in the dog class? No, speak if it's a
Okay.
static method. Yes. Can it be edited in the dog class?
Oh yes. Oh yes, it can. It can.
Okay. Okay.
It
All right.
can.
Thank you.
Yes. You're welcome. For the dog class is inheriting everything inside of what has been implemented here. And when we implement that, it is going to be the preferred method when we call it. It wouldn't look at the fallback method. It wouldn't look at the prototype. It will just look at the object itself. So I can when we have static speak, we can also have static speak here. But then this static oh, this is a mouth twister. This static speak is going to be chosen in favor of this static speak. Well, if we don't have this here, it is going to fall back to this. It is going to fall back to that.
All right. I understand that now. Thank you very much.
All right. Thank you very much. Thank you very much.
Thank you, everyone.
All right.
Have a good
Good night.
night.